Evening from the College of Charleston newsroom. I'm Margaret Tidings, representing Group 6 this evening. Tonight we'll be looking at a comparison of the Red River and the 1994 Central Georgia floods in order to inform the public about the dangers of flooding. The new FEMA director has asked us to focus on these two floods specifically because of their relevance to the upcoming NOVA program on rivers and flood hazards. To begin, we will take a quick look at the devastation of the 1994 Central Georgia flood. Numerous parts of central and southwestern Georgia were completely devastated by flooding due to the massive amounts of rainfall from Tropical Storm Alberto in July of 1994. Communities and towns were swallowed by flood waters because of streams reaching their peak stages and discharges far beyond record floods before. All of these floods caused 31 deaths in surrounding towns. 55 counties were declared federal disaster areas by President Bill Clinton, and several different water systems were unusable for up to 3 weeks. People traveling on nearby highways were disrupted as roadways and bridges were being topped with floodwaters. 1,000 bridges were shut down while the flooding was occurring. 500 bridges were temporarily closed off after the flood water ceased to repair them, and 125 bridges had to be replaced. The two main highways, 75 and 76, located close to Macon, Georgia, had to be closed for several days. The estimated damage of the floods and bridges was about $130 million. It was also said that small dams were failing after floodwaters were overtopping, and water located in small lakes and ponds were emptying into local streams. As a result of this, sinkholes were forming where homes were situated, completely destroying them. All of the farms located in the area affected by the storm had major crop damage from the excessive amounts of rainfall and floodwaters. 471,000 acres were completely destroyed, with about $100 million worth of damage. The main cause of the flooding was a result of Tropical Storm Alberto. This storm formed into a tropical depression in the Gulf of Mexico on the 30th of June in 1994, and was first seen on land in the morning of July 3rd. It was losing its energy quickly and therefore downgraded to a tropical depression by the late afternoon. The remains of Alberto floated to the north of Atlanta on the morning of July 5th, but suddenly changed its direction to the southwest. Due to the slow movement of the storm and the surplus of tropical moisture, these combining factors produced excessive amounts of rainfall. The highest total amount of rainfall was recorded as 27.6 inches, and the highest total 24-hour rainfall was 21.1 inches. All of the rainfall from Tropical Storm Alberto caused extreme flooding in the Flint and Ocmulgee rivers along both of their tributaries. Destructive flash floods happened in the suburbs of Atlanta to Macon during the night of July 4th and the morning of July 5th. As the heavy rains continued to travel south of Atlanta, even more damaging flash flooding was taking place in the small town of Americus on July 5th and 6th. The Muckalee Creek was greatly affected by the immense amounts of rain falling and several local dams failing, causing the water to peak at a discharge of 35,500 feet per square mile. This was about 4 times greater than any other 100-year flood discharge. 20 miles down south of Americus, the gauging station on the Kinnafony Creek in Dawson had a peak discharge of 24,000 feet per square mile on July 7th. As the tributary flood waters were combining together, it moved downstream into the Flint and Ocmulgee rivers, and the flood discharges greatly exceeded the previous 100-year flood discharges. The peak discharges that were greater than the 100-year flood discharge was recorded at the Flint River gauging station from about Lovejoy to Bainbridge. And the town of Montezuma, the Flint River peaked on the 8th of July at a stage of 6.7 feet higher than the previous record flooding of 1929. Also in Albany, the Flint River peaked at a stage of 43 feet, which broke the previous record by about 5 feet in the 1925 flooding. For the Ocmulgee River, it also surpassed to the 100-year flood near the town of Joliet. At Macon, the river peaked on July 6th at a stage of about 35.4 feet, which exceeded the 1990 flood. Changes in how the floodplain is set up and the downstream river channel are the source for the changes in the stage and discharge relationship. Let's now take a look at the flooding of the Red River. The Red River flows between North Dakota and Minnesota northward into Canada. The Red River has been prone to devastating floods over the years, putting many people's lives at risk. This flood has been reoccurring since as early as 1770. Many people in this region have stayed here because of the fertile land for farming which has been created by the flooding. They have taken many measures to reduce the devastating effects of this massive flood, such as using sandbags to protect their homes, building levees, dikes, and flood walls. Although these measures may have helped to some extent, the weather, geology of the land, and nature cannot be prevented, and the river will undoubtedly flood again. In April and May of 1997, a devastating flood took place on the Red River. So what causes the Red River to flood so repeatedly? There are many factors that play a role in the flooding of the Red River. Heavy amounts of snowfall in the winter months can cause substantial amounts of snowmelt flowing into the river in the spring. If the river banks cannot hold this large amount of snowmelt within its bed, it will overflow, resulting in a flood. In the case of the 1997 flood, there was a large amount of rainfall and later a snowstorm. There was also extremely high temperatures, causing the melting of the snow to occur more rapidly. The conjunction of the high amount of precipitation and the high temperatures caused large amounts of water to enter the Red River, resulting in a tragic flood. The topography of the floodplain of the Red River affects the flood magnitude. The Red River floodplain is actually an accident glacial lake bed. This has caused the landscape in this area to be like a valley and very shallow. The floodplain is very flat, allowing the floodplain to be very large and spread out over a large area. Due to the lack of slope, water can also collect in many areas. Another cause of the flooding is ice dams. These occur when chunks of ice from the frozen snow do not completely melt while flowing down the river. Those chunks can get caught up in certain areas such as bridges, resulting in a blockage. Those blockages result in flooding. The causes of this flood are mainly due to natural factors. However, humans do have some effect. Infrastructure such as bridges can cause an increase in the magnitude of the flooding. This is because bridges can cause ice jams to occur. There are various ways in which the people in this region try to protect their property. One way is sandbagging. The sandbags create a temporary barrier to keep the water from reaching certain areas. The entire community in this area takes part in assembling these sandbags in emergency situations. Another way to help protect property is through the construction of levees and temporary or permanent dikes. These structures help retain the water. Differences between the Red River flood and the Central Georgia flood. The causes of these two floods have many similarities and differences. The Georgia flood was a flood that does not have a reoccurring history like the Red River flood. The flood in Georgia was mainly due to the excessive rainfall from a tropical storm, while the Red River flood had numerous geological causes. Rainfall has had devastating effects on both floods. Rainfall has had dramatic effects on the magnitude of the floods as well. We have several recommendations on how to prevent flooding in different areas. First, restricting the water flow of a river by building dikes. Planting trees along a river that will prevent silting. Having a better monitoring and relief processes before, during, and after major floods. Dredging and straightening rivers to prevent floods. Understand where your home is located to know whether you are located in a floodplain. Also elevate and reinforce your home. Always evacuate when you know a flood is about to occur and secure your home.